Hello guys, welcome to Get a Late channel. Today we are discussing about serializable schedules. And what is serializable schedules? Serializable schedules are the congruent schedules of which the output of congruent schedules is equal to if any one of the serial schedule, then that congruent schedule is called serializable schedule. So for n transactions, n factorial serial schedules will be there. Are possible. So if our congruent schedule output matches with any one of these n factorial serial schedules, then that congruent schedule is called serializable schedule. So for checking serializability, first you need to calculate the output of our congruent schedule, and then you need to calculate the output of n factorial serial schedules, and then we need to check one by one. So, but this is time complexity. This takes very much time. So scientists discovered a method. First one is conflict serializability. Second method is view serializability. By using conflict and view serializability, we can simply say that whether our congruent schedule is a serializable schedule or not, and note it down. We're going to discuss about this deeper now. Now look at here. This is a conflict serializability. If our schedule is conflict serializable, then it is automatically view serializable. But if our schedule is view serializable, we can't say it is a conflict and view serializable. We understand what is view serializable in our next upcoming lectures, but now we can understand what is conflict serializable. Conflict serializability, if you take two transactions T1 and T2, they both should be of different transactions. So first step is valid, and at least one of them should be write operations. And if I take read P and if I take write Q, this is conflict serializable. This is conflict. You see, this is a conflict like this. And second possibility is T1 and T2 is there. One is write of Q, another one is also write of Q. This is another conflict here. And you take like this here. This is T1 and T2. This is write of Q. This is read of Q. This is a conflict. And the data item should be here P na. So here it should be P only, not Q. Q is there. Because they operate on same data item. Data item is P here. So here also it should be P. Here it is Q. Here also it should be Q. Q. Here also it should be Q. If it is both read, let us say T1 and T2 are there, and I'm saying read of Q. This is read of Q. Conflict serializability can't be applied here because both are read operations. Here write read is there, write write is there. Here for these three conflict is applied. For this it is not applied. Like this we check which is conflict serializable or not. Now we are going to take an example and understand what is conflict equivalence between two schedules. Note it down. Look here, look this example. This is transaction T1, this is transaction T2. Now our intention is to check whether this schedule is conflict serializable or not. So here read P is there, write P is there, read P is there, write P is there, so and so they have given. This is the different data item, this is a different data item. So for understanding conflict serializability, we need to know what is precedence graph. Precedence graph is necessary. First there is two transactions now. So write two transactions here like this. T1 and this is T2. Now I told you there should be at least one write item. Here I can see that between write and read there is a write, and between write and read also there is a write conflict. Go from top to bottom. Go from top to bottom. Here write to write. This is also there. So look at this arrow, T1 to T2 is there. So I am drawing an arrow like this, T1 to T2. And now read P, read Q. this is the different data item, PQ are different data items, so the conflict is not possible here. And you look at here, this is read queue, this is write queue, so a conflict is possible here. Even you write queue, the conflict is possible here. If it is 2 arrow, 1 arrow is enough, and T1 T2 another arrow will come, so 1 arrow is necessary. If so, here there is no cycle, in precedence graph. Let us say if any cycle came in precedence graph, then we say that that transaction is not conflict serializable. But here there is no cycle, so we say that this is conflict serializable schedule. So this schedule is conflict serializable schedule. If you find this one here, let us say, then there is a arrow from T1 T2 T1 also, then it would be like this, then it won't be in a conflict serializable state. Note it down, this is very important. No cycle should be in precedence graph, then only that schedule will be conflict serializable, or else it is not conflict serializable. This is all for today's lecture, guys. In our next lecture, we are going to discuss about conflict equivalence between two schedules. And thank you for watching this lecture.